This tutorial video will demonstrate the device data view. The device data view is a useful tool that can be found in MT Manager. It allows you to visualize and test low-level communication with your Xsens motion tracker. This can be particularly useful if you are planning to use your motion tracker in combination with a microcontroller or as part of an embedded system. In order to learn more about the XBus low-level communication protocol, please refer to our low-level communication protocol document. Let's start by opening MT Manager. After establishing a connection with your motion tracker, the device data view icon will become available. It is located in the lower toolbar and shows a terminal connected to a motion tracker. The device data view is divided into 3 sections. At the top, we find the message composition field, where you can create and send low-level messages. The middle section shows all messages that are sent to the motion tracker. And at the bottom, we can observe all messages that are received from the motion tracker. As we have already connected an MTI 630 to our PC, we can immediately see a flow of hexadecimal data packets here. These are all data packets sent out by the MTI. We can use the radio buttons at the bottom right to automatically parse this data. Once we do this, we can see that the received messages are MT Data 2 messages, and they contain the Euler angles, roll, pitch, and yaw. We can also double-click on one of the incoming data packets, and a new window will show how the data packet is constructed and translated. Let's close this window and start communicating with the motion tracker. As the motion tracker powers up, it automatically enters measurement mode. In order to force the motion tracker into configuration mode, we can send the Go to Config message by clicking the button at the top left. As you can see in the bottom view, the motion tracker immediately stops outputting measurement data and returns to the Go to Config acknowledgement message. Next, we can compose another message by choosing one of the messages from the drop-down menu. As an example, we will choose the Set Output Configuration command. By default, the data field of the command is empty. Sending the message as it is now would configure the motion tracker to output nothing at all. Instead, we can click the Edit button and start adding outputs to the message. Let's say that, in addition to Euler angles, we would also like to receive acceleration and rate of turn data. In that case, we increase the number of items to 3. The first item we add is the Euler angles output. The abbreviation XDI that is shown here stands for Xsens Data Identifier. Next, we can choose the data representation formats and the output frequency. Leaving the output frequency field at 0 will automatically configure the highest output rate available. For now, we will choose an output rate of 10 Hz. We repeat the procedure for the second and third items, choosing acceleration and rate of turn. Finally, we click OK. The message field now shows the full low-level command that we are going to send. In line with the documentation we referred to at the start of this video, the message consists of a preamble, a bus ID, a message ID, a length, a data field, which in this case is made up by 3 outputs we have chosen, and finally, a checksum. We send the command by clicking the Send button. In the Send to Device view, we can see that the message was sent, and in the Received from Device view, we can see that the motion tracker replies with the output configuration message. This confirms that we have successfully modified the output configuration. After sending the Go to Measurement command, we can see that the motion tracker now outputs Euler angles, acceleration, and rate of turn data, all at a rate of 10 Hz. There are many other commands and functionalities that can be evaluated using the device data view before implementing it in your actual design. Some examples include applying and storing of orientation resets, running an in-run compass calibration, configuring and evaluating synchronization options, and requesting and setting device configuration parameters. Finally, if your motion tracker product supports a string output mode, then the device data view can also visualize these messages. We have reached the end of this tutorial video. If you have any questions, or if you need help with your application, please visit us at BASE. BASE is a growing knowledge base on which you can find frequently asked questions and a community forum with active Xsens support staff.